Okay, so recall what the slope formula is. You take the y variables and you subtract them, and you take the x variables and you subtract them, and then you divide, right? What do we call the numerator? What do we call this? The rise, and the bottom is the run. Okay? We always start with the second point, okay? So first of all, let's work on the dotted line. Let's get the points. So the first one is 1 comma 75. Are people okay with that? Why is it 1 comma 75? Sure, I can turn the lights off. Will you hit it? Thank you. 1, and then this value is 75. There's always the x and then the y. Okay? 50. There's 2 ticks between 0 and 50, so each tick is worth 25. So 25, 50, 75, there's that point. What's this point here? 2, 150. Good. And then when you go to do the slope calculation, what I wrote on a lot of your guys' pages was like a line like this. You got to connect the y's and you got to connect the x's. Okay? So for the first difference, which point do you start with? The second one or the first one? So which one's the second one? The 50 or the 75? Always just choose the point on the right. That's the second point. And then if we do that, we're all going to be on the same page. Thanks. So 150 take away 75. And on the bottom we go what? 2 take away 1. Okay? So you can see that this point has been transferred to the other point by going 1 over and 75 up. Okay? Which the calculation here agrees with. Do the top calculation, do the bottom calculation, and you get 75 over 1. It's identical if you were just to draw some lines and make a triangle. How much over? How much up? See that red line? How much over did I go from 1 to 2? Just 1. And then from 75 to 150, I went up 75. Okay? So this is the slope calculation. Question? Okay. All right, let's do the next one. What's this point down here at the bottom here? 1 comma 50. And it doesn't matter which point you use on the line, as long as you use a perfect point. So let's use this one here. What is it? 2 comma 100. So without even thinking, without even doing a calculation, what happened to the x? Look at my pointer. See how it's 1? What did it become? 2. So what's the change in x? 1. Okay, it went over 1. Okay, and the y value is 50, and then it became 100. So what's the change in y? 50. Okay, so that's what we should expect when we do our calculation. y2 minus y1 over x2 minus x1. The y values are 150, 100, take away 50. And the x values are 2 and 1. So 2 take away 1. Do those calculations separately. You get 50 over 2. Oops, pardon me, 50 over 1, which is just 50. Okay, the one above is just 75. And then in terms of working with slope as a rate of change, you always think about units when they say the word rate of change. So what are the units in the y? Kilometers. What are the units in the x? Hours. It's always the y over the x. You can see in the formula, the y over the x. So kilometers on top of hours. What unit is this? It's just speed. Okay? So rate of change, Speed is the most common example. It could be anything though, like if you guys have a job, then you could plot your time on the X and then your rate of pay, the money on the top, and then you get dollars per hour, okay? If this Y value was dollars, then you'd have dollars per hour, and that would be your rate of pay. If I say rate of pay, you know what I mean, but if I say rate of change, you're like, what the heck are you talking about? Okay, if I say rate of speed, you know what I'm talking about. Rate of change is just encompasses all rates, okay? And slope calculates rate. And all that's summarized here in the bottom here, okay? The independent variable is X, the dependent variable is Y, okay? The independent variable is the thing that you change, okay? You change, and then the dependent variable is the result. So if you go to work for 2 hours and then you feel tired and you bail, do you get paid much? No, you decide how long you're at work for, and then the result is how much you get paid, okay? If you can tough it out and stay like a 10-hour shift, get paid some overtime, okay, you decide that on your life, and then the result is you get paid more, okay? So you decide the independent variable, and it's always time, okay? And then X is always time, and then the result is in the Y-axis. And then they write down these formulas here, which I really don't think we're going to have to deal with that too much in 20-3. But it's just it's like, I don't know if you guys have seen this since like grade 9 or 10C. Yeah, it's not going to really affect us too much, I don't think. Mx plus b, this is just the equation for a line. But I think we'll move on from that, and I don't think you need to worry about equations. Don't worry about the equations. Okay, example 2 we'll just go through together. We won't actually do any work, we'll just read it together. So this guy's an electrician's assistant. He doesn't get paid very much at all. 12 bucks an hour. So what is the dependent variable? The dependent variable is his earnings. It's how much money he gets. Okay? Write an equation that shows the relationship between hours worked and income. Well, although equations might be hard, all of you should know this equation. It's so basic because you all do it if you have a job. It's just the amount of hours you work times the rate, obviously. And the rate is your slope. Okay? And then the result is your cash. Okay? Okay, so this guy's equation is 12.25H. And the result will be his earnings E. Then they go ahead and they graph it. Okay? So he must have just plotted for 1 hour, whatever, this doesn't matter. Let's move on. How much will he earn in 5 hours? That's, you just go find 5, and then you go up, you find it, so roughly 60. If he earned about 180 on the job, how many hours did he work? If the graph was large enough, you'd go up to 180, and then you'd find out how many hours. You'd have to extend this graph. I think we should just move on. And the work's there if you want to see it. In the Build Your Skills, I'll help you understand some of this stuff. So Reggie here is starting to practice for a marathon. He walked 30 kilometers in 30 minutes. What is his average rate in kilometers per hour? Okay, so look at this unit. It's kilometers on top, hours on the bottom. So how many kilometers did he walk? 3. And how many hours did he walk for? 30 minutes. It's weird, right? So take a look at this unit, and take a look at this unit. Is different, right? So you have to be consistent, and 30 minutes is an easy one, right? 30 minutes would be half the clock. Okay, so half an hour. So you can put 0.5 down here. And when you divide 3 by 0.5, you'll get 6 kilometers per hour. So now you know this person's speed. The independent variable. What is the thing that you change? And remember, it's the x. And remember, for rise over run, x is in the bottom. X is in the bottom. So the independent variable here is the denominator, which is distance or time? Time. Time is in the denominator. Okay. The thing that he can change is how long he runs that marathon for. If he does not change his pace, so he does not change his speed, how long will it take him to walk a 36-kilometer marathon? So we have to use this formula, y equals mx. Okay, remember that y is the dependent, x is the independent, and m is the slope, or the rate. Okay, so we know his rate. His rate is 6. Okay, so y equals 6x. That's your equation. Now what did they give us? He gave us a 36-kilometer marathon. Sure.
Why did you put 6 up there?
6? What do you mean?
Oh, came on.
Okay, so the dependent variable is the distance. It's always distance time, like this. Okay, so this 36 kilometers is a distance, so we have to put that in for the y. And then you can solve for x that way. This is a pretty tough question. If you know Science 10 or Physics 20, then you know that speed is just d over t, like this. And if you wanted to solve for how long, you can just cross multiply. T equals d over v. And you just go 36 kilometers divided by 6 kilometers per hour. That would be a way easier solution than trying to do this independent dependent with y and x. Like, keep it simple, do what you already know. V equals d over t. So the answer here is just 6 hours. 36 divided by 6. If I give you a question like this, I likely will not mandate this y equals mx business, because it's kind of weird. Yeah, this one too, write an equation. So when we do the review, I'll take a look at the exam and I'll make it very clear what's expected of you. So right now we're still trying to figure out this y equals mx. Okay, so this person, Janita here, her car needs to be fixed and she borrows $600 from her brother to pay the bill, and she repays her brother $40 a week. So in this one you have to use y equals mx plus b. So these kinds of questions aren't even really that fair, because this is 10C stuff. They don't really teach it in 10-3. So I'm just going to do it really quickly on the side here. Okay. For a linear equation, the b value is the y-intercept, and it's the start. Okay, and m is something you know, it's the slope. And then you just keep y and x in your equations. Y and x will always be there. Y, x, just leave. You always just leave it yx so that you can have an equation. Okay? So the y-intercept is the start. So think about this person. She has to borrow $600. So is that a plus 600 or is that a minus 600?
Well, depending on what you're talking
Yeah, so like if you're,
about her, it's plus 600.
well, if you're talking about her, it's actually minus 600 because she is 600 in the hole, right? And then if she's going to pay back the bill, $40 a week, okay, so it's like you're at minus 600. Then if you pay back 40, you're at minus 560. And then you pay back 40, and then you're at minus 520. And you keep going in this sense until you pay it off. It's just a pattern. It's just a pattern, okay? So for the formula, I'll leave spaces for M, and I'll leave spaces for B, okay? What do I put in for B? That's the start. What do you start at? And you put in here minus 600. So she's in the hole to start. And then she repays her brother 40 per week. That's what this should say. $40 per week. This is a rate of change. Rates of change always have 2 units, and they use the word per. This should say per, like kilometers per hour, dollars per hour, $40 per week. Okay, so this is the M value. So 40. Okay, so rewriting this so it's nicer, 40x minus 600. Now with this, you could solve for anything you want, okay? So x is weeks and y is dollars, okay? So obviously she would just, you want to figure out like, when is she going to break even? Okay, that's this type of problem. When would you break even? Okay, so they want us to graph this information, and I'm going to skip, like, what it would look like is 600 down here. Then she's paying back 40 a week. So just sketch this in, and I'll show you what the slope would look like. It would be in 1 week. In 1 week, she pays back 40. In 1 week, she pays back 40. In 1 week, she pays back 40. And that's all it would look like. It's like a staircase. 1 over, 40 up. 1 over, 40 up. 1 over, 40 up. And that's all a line is. It's constant change. The delta x, the delta y. Okay? Delta y would be 40. Delta x would be 1. And the units would be dollars per week, dollars per week, dollars per week, dollars per week. And eventually, you would get to 0. So don't worry about this graph on the left. Okay, the next one's commission. Commission is very applicable to life. If you ever get a job in sales, you very might well be on commission. So like before Future Shop got taken over by Best Buy, those guys were on commission. You'd walk into Future Shop and you'd have these like young guys or young girls trying to talk to you and like trying to sell you a TV. And it's like, just leave me alone, I want to browse. But the reason they're so hardcore is because they are on a commission. I think Sport Check might be on commission. They are? Yeah, so the more things you sell at Sport Check, you're going to get a nice little payday. Car salesman, this is huge. Okay, furniture stores, for sure. Like if you go to the Brick, the guy's trying to sell you hard. He's like, okay, you're going to buy this couch. It's going to be awesome. And you're like, just relax, buddy. I don't need a coach. I'm just looking around. But it's because they want to get paid. The more they sell, the more they get paid. So the 12% commission is the rate. Okay, so let's start with 6A. Calculate how much commission George would earn if he makes sales of blah, blah, blah. Okay, so the commission equation is the percent times the sales. Okay, you just times the two things. Whatever the percent is, times your sales. Okay, so this 12%, how do we write that as decimal? 0.12. Okay, 12% divide by 100, that's what percent means. You get 0.12. Sure. Okay, so you always convert percents to decimals, and then you just got to put in his sales. So 500, 1,000, 2,000, just add those up. It's 3,500. So he's going to get 12% of 3,500. That's a pretty good deal. Okay. And it gets 420 bucks. Okay, and then it says write an equation that shows the relationship between his sales and his commission. Well, we already did that. It's above here. Okay. What is the independent variable? So that's my question for you. What's the thing that you change as a salesman? Is it the percent? Or is that fixed? That's fixed. You walk into the company, they're going to tell you what commission you get. If you don't like it, they're probably going to hire somebody else. The one thing that you can change, though, is how much you sell. If you're a good salesman, you're going to get paid more. And people that want to make money in life, they want to be rich, you want to own a business, a lot of people start in sales. You get a lot of skills. Like Mr. Atchison and Mr. Balba were talking on ENN. Like, what's your passion? Well, I don't know. I like money. You like money? Oh, well, then maybe you should get into sales. And it could be anything. Like my girlfriend's dad, he sold Xerox machines. Right? He worked for Xerox. He sold photocopiers. Photocopier. Okay? It could be anything. Especially in Alberta with oil as one of the #1 driving forces, you could sell like random oil parts for refineries. Could be anything. Okay, you just got to get in and you got to learn like sales techniques, and you learn and you move on, you get skills. Okay, my neighbor at the lake that I have, it's my girlfriend's lake property. The neighbor there, he started as a car salesman, and now he owns Cash Canada, and he's like really rich. And he started in sales because he picked up skills, learning how to deal with people and sell them things. Okay? So he didn't have education. All he did was read books and gain experience. And he got rich. Okay, so in this case, independent variable, what's the one thing that you can change? Well, it's the sales. Okay? So in our equation, X is independent, it's your sales. The slope, the M, the percent is fixed. The Y, the result, this is the result or the dependent variable. This is the dollars that you get to take home to mama. Okay, so they want us to graph this. I don't want to do this. Okay. If George earned a commission of 210 bucks, how much did he sell? So this is our formula. He earned 210. So that's the result. 210 is the result. M is fixed. We know it to be 0.12. How much did he sell? That's the thing that you can change. That's X. How do you solve a problem like this? What do? Divide out the coefficient. I think you've all have seen this in your life. Just a matter of remembering what it looks like. 200 divided by 0.12, or 210 divided by 0.12. So 1750.
Okay, wait, so like,
How did I get the equation? This is the same equation from the last page. The dollars is what you earn, M is your commission rate, and X is the amount of things you sell.
why did you cross off the default? Why won't you just divide 0.12?
That's what I did. I divided by 0.12. It cancels.
Okay, so you
Yep.
isolate the variable.
That's what I did there. Yep. I isolated the variable. Good. We good on this? Okay, now we can do some graphing. It says that Reg timed himself jogging on a race course. He passed the 300-meter point 1.5 minutes after starting, and the 600-meter point after 2.8 minutes. Show this on a graph. Okay, and we don't have to be super accurate. How come mine's not showing up? You have this on your page, right? Okay. So this 1.5 minutes, it's going to be somewhere in between 1 and 2, obviously, and you go up to 300. So it should be somewhere here. So right beside that point, you can mark this in. 1.5, 300. Jaden, come sit up at the front here. Pick up your stuff. The other point is 2.8, 600. All right. And then it says, what is the average rate? So when they say, what is the average rate, what are you trying to solve for? Slope. So those of you that have been here the whole time, when you go to do slope, you subtract the y's. So what do I subtract? 600 and 300. That's the numerator. Now the denominator, 2.8 subtract 1.5. Okay, let me help you jot that in. Slope formula, subtract the y's, divided by subtract the x. What's the unit for the y? Meter. What's the unit for the x? Minute. So our answer should be meters per minute. Looks like 300 over 1.3. Put that in the calculator. 300 divided by 1.3, I'm getting like 230, whatever, 0.77 meters per minute. So that's pretty fast. 230 meters in a minute. I don't think I could do that. I'd probably fall over, start gasping for air. 'Cause I'm out of shape. How come they have a different answer than us?
They took the decimal away.
Yeah, why'd they do that? Think that's a typo?
Never trust books.
Yeah, that might be a typo in the answer. Yeah, why? 2.8 minus 1.5 is 1.3. Then they changed it. Scroll up. Sure. Zoom in. Maria is filling a rectangular swimming pool with water. She knows that the pool will hold about 13,500 gallons of water. After 45 minutes, she estimates that there are approximately 2,250 gallons of water in the pool. At what rate was the pool being filled? So what do you know? 2,250 gallons in 45 minutes. So what's the independent and what's the dependent? What's the one thing you can control? Don't you control how long you fill the water for? And isn't X always independent? The time? Isn't time always independent? Yeah, time is always independent. X is always time. And then gallons is the result, so that's the dependent. Okay, and then when you do slope, which is rate, rate is slope. It's always the Y change over the X change. So 2,250 gallons in 45 minutes. You divide those two things, and your unit is gallons per minute. Okay? Just like kilometers per hour or dollars per hour, it's gallons per minute. It's a rate of change. So 2250 dividing 45, 50 gallons per minute. How long will it take to fill the pool at this rate? Okay. So this is where you go with one of these. Y equals mx. We know what m is. We just solved for it. And we have to figure out what are we trying to find. Are we trying to find y or are we trying to find x? Which one are we trying to find out? See how it says how long? How long means what? You're searching for a time. Which one's time, x or y? Okay, so we need x. If we need x, that must mean we already know what y is. What is y then? Good. It's how much it takes to fill this bad boy up. Now we solved a problem like this earlier, where it was number equals number x. What do you divide out? The number in front of the x. So 13,500 dividing 50 is x. Okay? So you divide by 50, divide by 50. 13,500 divided by 50 is 270 minutes.
There's just the rulers.
I gave him to physics guy. All right, Tom the truck driver. First leg of his trip, travels 380 kilometers in 5 hours. Okay, if he drove at the same speed the whole time, what's his rate? This one's easy. What goes in the denominator? Time or distance? Yeah, clearly time. Because you want kilometer per hour, right? So 380 in 5. 380 in 5, well, do the division. I get 776 in 1. That's what happens when you press the divide button. It just figures it out for 1. Okay? So if it's 380 in 5, go 380 divided by 5, you get 76 in 1. So that's what his rate of travel is, 76 kilometers per hour. After the 5th hour, he speeds up. Okay? And after 9 hours, he has traveled a total of 764. What was the average rate of travel after he sped up? I don't know. This seems weird. After the 5th hour, he speeds up. After 9 hours, okay, this is confusing. Don't care. Moving on. I'll never give you a confusing question. Like, is it 9 hours after the 5th hour, or is it 4 hours after the 5th hour for a total of 9? It's confusing, right? I would never build you a question that's confusing like that. All right, let's do Miriam here. Reads a book at 0.6 pages a minute. How long will it take her to read the entire book? 321 page. So what we need to do is identify which is y and which is x. Which one's y? The top number, or the top unit. And minute is the bottom, okay? So, when you go to your formula like this, y equals mx, and it says how long, you're searching for x. You want to know what x is. So that must mean you know y and m. Y is how many pages she's read. M is the rate. And how do you solve a problem like this? Number equals number x. Isolate it out by dividing 0.6. So 0.6, 0.6. So it looks like 535 equals x. So it would take her 535 minutes. It's like 9 hours. So if you like reading, there's a 9-hour book. I don't know, maybe you guys like reading, you could time yourself. How many pages in a minute? Now the next one says, well, what about after 2 hours? So this is like, if B was less confusing, it's the exact same question as B. After 2 hours, how many pages will she have read? Well, in our formula, if we know the time, all we have to do is put it in for x, and we'll solve for the number of pages y. So 0.6 times 2 is 1.2. Oh, that's in hours. And our so I screwed up. We gotta start over on this. I apologize. Just one line. Because it says 2 hours and our unit is minutes, we have to make a small adjustment. 2 hours times 60. Okay, this is 120 minutes. So just a small adjustment. X is the time. It's 2 hours, but we have to write it as minutes. So 0.6 times 120 looks like 72 equals y, and that is a page. 72 pages. Be more specific. What's your question? Like, do you understand how I got this equation? Do you understand the equation? M is the slope, x is the time. And the question gave us 2 hours. I just did a quick times by 60 to get the number of minutes, because our unit is in minutes. 60 times 2. 60 minutes per hour, and there's 2 hours. Good now? No problem. Okay, so practice your skills is the homework, and that gives us about 20 minutes. You've already accomplished 1 and 2 last day. So basically, you have question 3 to 7. Okay, so 3 to 7. I'm going to be walking around helping.